So now, after the explanation regarding the quantitative and qualitative method of the concerned topic, let me explain to you the limits and constraints to the ability to adapt. Students, there are constraints and hurdles that limit the society and ecosystems from adapting to climate change, even while adaptive capability can be improved. Some limits are biophysical, such as when coral reefs bleach beyond a certain point, glacial melts, or heat and humidity level rise above what the human body can handle. Other limits are social, economic, cultural, or political. So, students, now let me take you to the climate resilient development, adaptability, and equity. The country which are excluded from socio-economic groups often face larger climate related problems than other because they are less able to adapt, have less say in decisions, and have less access to adaptation funding and services. To make individuals more resilient to such adversities, investments need to be made in public goods such as water, infrastructure, early warning systems and health services, as well as social protection, livelihood, diversification, education, gender sensitive policies and inclusive governance processes. International climate finance mechanism, capacity building programs and technology transfer agreement under bodies like UNFCCC are to help with these kinds of activities, at least in theory. There are still issues concerning how well they work, how easy they are to use and how effective they are. The idea of climate resilient development that is mentioned in the recent IPCC report analyzes that climate action, sustainable development and poverty reduction must all move forward at the same time. Improving adaptive capability is a key part of this integrated agenda. For geography students, this involves looking at adaptive capacity not just as a technical feature, but also as a process that is different in different places and is politically disputed. The process shows larger pattern of power, inequality and environmental change. Now, let me also explain to you the linking adaptive capacity which is related to the course tool and different types of methods. The tools and methods that help planners, managers and communities go from knowing about climate threats to making a real plan or how to adapt by giving them easy to understand climate data, scenario analysis, organized methods for assessing vulnerability and advice on how to adapt. For instance, by using Climate Wizard to map past and future rainfall and temperature trends, water management or agriculture planners can find hotspots where they need to invest in storage, irrigation efficiency, drought resistant crop or ecosystem restoration to make the area more adaptable. The Adaptation Wizard's 5-step process, which include getting started, assessing current and future vulnerability, identifying options and monitoring outcomes, also help organizations systematically build their own capacity to respond to climate change. In short, adaptive capacity is important because it connects climate hazard vulnerability and their actual effects. It decides if climate change will cause a crisis, require careful adjustment or create chances for development that is more sustainable and fairer. Students, for geographers and other students, dealing with adaptive capacity requires combining points of view from both physical and human geography, using tools and assessment carefully and understanding that creating capacity is both a technical as well as social and political process. So now, let me explain to you adaptation through mainstreaming states policies in context of India. Students, Climate adaptation has been incorporated in the government policies and programs in Indian state in terms of agriculture, water management and disaster preparedness. This mainstreaming helps streamline the process of adaptive planning in a more sustainable fashion through harmonizing development planning with climate targets. It has been combined with a strong local governance, stakeholders interaction and science policy interaction, facilitating agriculture resilience and climate vulnerability of millions of people who rely on livelihoods. Now I would like to take you to Bangladesh and describe you the adaptive capacity of Bangladesh. You may be knowing about mangrove sandy coastal restoration. Students, mangrove reinstatement on the coast of Bangladesh offers a natural shield against tsunami, storm scare and erosion. Controlling the human security, mangroves not only improve the security of the coastal communities by mitigating the effect, but also the fisheries production and stabilization of the shoreline. Their thick root system entraps sediments and minimizes erosion along the coastline and enhances deposition along the coastline, biodiversity and livelihood to the fishing population. Now, I would like to cite example from Africa, and I will cite Rwanda, where solar powered is used as an adaptive capacity. The project in Rwanda is solar powered Kisox. This is used to provide off-grid energy solution which enhances digital inclusion and supply of clean and renewable energy to remote communities. The kiosk car charge with phone power, internet and power to small business, boosting economic conditions and capacity to recuperate in climate conditions. This leapfrog technology is useful in bridging climate adaptation and the overall sustainable development and reduction of poverty. Now I would like to cite example from East Africa, neural weather forecasting and solar pumps. The Agriculture Society in the East Africa are enjoying AI powered weather predicting system and solar powered water pumps. The AI system give customized real time weather data that are important in making planting and irrigation decisions to enable farmers to better control climate variability. Solar pumps use renewable energy to extract water, which will lower dependence on unreliable rainfall and enhance agricultural activities and water security in drought affected areas. Now let me take you to the global examples: urban greening, roof cooling and coral restoration. Students, in the world, restoration of coral reef is based on the planting of heat tolerant species in coral in order to fight occurrences of bleaching caused by increased ocean temperature. Such works maintain fisheries, tourism and coastal protection benefits. Planting of trees in urban areas, development of green corridor and expansion of parklands in cities across the world decreases heat islands, improve air quality and increases urban resiliency to extreme heat and floods. Roof cooling measures, just like green roofs, include reflective surfaces and plant covering that reduces the temperature and consumption of energy in building. All these tactics offer several benefits of resilience, which are better human health, ecosystem service and climate mitigation co-benefits. So students, with this the chapter is coming to an end. Let me summarize in few words. The stepwise expansion explains the importance of adaptive capacity, which is facilitated and realized through novel context specific interventions in translating into direct climate resiliency outcomes within a variety of geographies and industries. The green roof approach in Basel represents a ray of coherent nature-oriented adaptation closely intertwined with mitigation and urban policy. The green roof approach in Basel represents a ray of coherent nature-oriented adaptation closely intertwined with mitigation and urban policies, which shows how urban areas can be in front line in promoting climate resilience and general betterment. All these above steps are highly recommended in this area of climate change. With this, I would like to end my lesson and suggest you a couple of questions. The first is, discuss spatial and equity variations in adaptive capacity across rural urban divides, gender groups and socioeconomic classes in India. How do tools like Climate Wizard and UK CIP Adaptation Wizard help with adaptive capacity assessment for preparing for local vulnerabilities?